Welcome to ChemVid, Structure of the Atom. Alright, so a lot of this will be a review, but some of it is new, so make sure you're paying attention, writing down your notes, and understanding what I'm saying. Alright, so, just so you can enjoy my little comic, it's the element of surprise, because it's a surprise face on the periodic table of elements. Okay, well, hopefully you like it, because I do. Alright, how does the size of the nucleus compare to the atom? So, if you recall Rutherford found out that we have a tiny little nucleus in the center, but there's mostly empty space around the atom, which means that the size of the nucleus compared to the size of the atom is, nucleus is really small, atom is really big, okay? So, when you're thinking about the size of an atom, atoms are extremely tiny, but even tinier than that is the nucleus inside. So how does the size of an atom compare to the tip of a sewing needle? Well, if you look at a sewing needle, we're talking not one atom, of course, too small, not 10, not 100, not thousands, not even millions. We're talking about like billions of atoms are sitting on top of a sewing needle. Alright? And we're going to learn all about how we find out how many atoms are here and there, and you'll be able to calculate those things. So, let's refresh. Size of the nucleus compared to the size of an atom, it's 1/100,000th. Okay? So if you had an atom, and the entire atom was 100,000 inches long, the nucleus would only be 1 inch of those 100,000. Okay? So we're talking very, very small. In fact, atoms are so small you can't see them with a microscope. They're so small that we use negative scientific notation, -10, in order to show how big an atom is. Or we use picometers. So when we're talking about the size of one atom, it has its very own unit. Its own unit is called the angstrom. And an angstrom is equal to 1 times 10 to the -10th meters. So like one hydrogen atom is 1 angstrom across. Okay? So angstrom is just another unit. It's a new one, but it just is a size and it represents a very small size, so we use it for atoms. Okay? Alright, the next part. What does the 10 to the -10 mean as far as the size of the atom? Well, it means it's very small. Okay, so we just went over that. Very, very small size. Atoms are extremely tiny. But how do we measure the mass of an atom? Well, as you may have guessed, the mass of an atom is extremely small. In fact, it's so small, we use atomic mass units. We have a new unit to represent how small the mass of an atom is. So instead of saying an atom is, or a hydrogen atom, weighs 1.6 times 10 to the -24th grams, we say it weighs 1 AMU. Lots easier to write. We can use dimensional analysis to get our AMUs into grams if we need it, and we can use our dimensional analysis to go from grams to AMU. Okay? So the reason why we like AMUs is because that's the mass on the periodic table. And they're so small we can't keep using scientific notation all the time. So we came up with new units. So now, angstroms is the length of an atom. Atomic mass units is what we use for mass of an atom. 2 new units that you need to know. Alright? Okay. So our subatomic particles are protons, neutrons, and electrons. Hopefully by now you have gotten that down. And if we look at the mass, you can see that our protons and neutrons have about the same mass. They differ on the tens, hundreds, thousandths place, alright? So they are very, very similar. And then the mass of an electron is so small that we consider it to be negligible. So when we start calculating the mass of an atom, we don't even care how many electrons there are because they don't do anything to affect our overall mass. They're so small that they are what we call negligible. Okay? Alright, so on the periodic table you have this beautiful you have the symbol up there, we have the mass and the name and the protons and everything like that. Like I said, the periodic table holds every answer you will ever need to know. So we need to learn how to read the periodic table and how to write these symbols and how to denote all these different changes. Okay? So first of all, what is a symbol? A symbol is the letter in the middle here. It's 1, 2, or 3 letters. The first letter is always capitalized. The second or the third letter are always lowercase. And it's a symbol which represents a specific atom. For instance, H represents hydrogen. That's his symbol. All right? So what does the atomic number represent? The atomic number is right up here. It's on top on the periodic table in class. It's in the middle, but wherever the top number is, that's the atomic number. And it represents the number of protons. So whenever I ask you how many protons does, I don't know, lithium have, you can look at the periodic table. Whatever that top number says, the atomic number says, that's how many protons. Lithium has 3, if you want to check. The nice thing about protons is protons will never change for an element. They always stay the same. Because the protons give an element its identity. So hydrogen, the reason why an atom is a hydrogen atom is because it has 1 proton. As we talked about before, all of our atoms have the same structure, right? Common origin, they're all made the same way. They all have protons and neutrons in the middle, electrons on the outside. So the thing that never changes and the thing that causes an atom to be that atom are the protons, because the protons never change. All right. What does the mass number represent? Well, the mass number represents the protons and the neutrons. So for just a few seconds ago, I told you that the electrons were so small in mass that we didn't really even think about them when it comes to mass. They're negligible. So when I ask for the mass number, I'm asking how many protons and how many neutrons there are. And here's where it gets a little tricky. On the periodic table, on the very bottom, you have what we call the average atomic mass. Now, this is not the mass number. This does not tell me how many protons and neutrons there are. The average mass number tells me, on average, what is the mass of a hydrogen atom. Because a hydrogen atom, or any atom, can have different masses. And we're going to go over why they can have different masses in a bit, but just remember, star it, note it. Average atomic mass on the periodic table. The mass number can only be calculated for one specific atom. Now there's another thing that can change. So neutrons can change, but also, what is the charge of an atom based on? How do I know if an atom is going to be positive or negative? If you told me protons and electrons, you're correct. In an atom, the only thing that has charge are protons, which are positive, electrons, which are negative. So if I have the same amount of both, then we call that a neutral atom. It has 0 charge, which all neutral atoms have. But let's say that I get rid of an electron or add an electron. I can either gain a positive charge or a negative charge. So our equation for charge is you take the number of protons minus the electrons, and that'll give you the overall charge for the atom. So there are many ways to write out what an atom looks like, and we're going to go over another one that has this format right here. But for right now, I want to go over 2 definitions. So turn over your paper. An isotope versus an ion. Do those sound familiar? Maybe from biology you might have heard of ions before. An isotope is an atom of a given element that has a varying number of neutrons. So it's like having a hydrogen atom with 1 proton, but a hydrogen atom can have 0 neutrons, 1 neutron, or 3 neutrons. They're still the same atom, they just have different number of neutrons, okay? So for an isotope, the number of protons stay the same. The number of neutrons differ, okay? And so that's why we use our mass number. That's where our mass number comes from. Protons plus neutrons. Since some of our atoms have more neutrons than others, you're going to have atoms with different masses, and that's why we need to take an average of them, and that's why the average is on the periodic table. Our next definition is an ion. So an ion deals with the other part of the atom that can change. It's an atom of a given element that has varying number of electrons. So this time you're looking at one single element. So we have hydrogen. We're going to use hydrogen again. Hydrogen has one proton and one electron in its neutral state. If hydrogen loses an electron, he's going to lose that negative particle, and he's going to become positive. We call it a positive charge. It's still hydrogen. He's just either lost or gained electrons from a neutral state. Okay? And for that, that's where we get our charge equation from. Charge is equal to the number of protons minus the number of electrons. Remember, protons always stay the same, but electrons can either be gained or lost, depending on what atom you are. Okay? So, between isotopes and ions, these can sometimes get confused. So, here's how I remember them. Isotope is based on neutrons changing between different atoms. And isotope is the bigger word between isotope and ion. Neutron is the heavier particle between neutrons and electrons. So the heavier particle has the longer name, the lighter particle has the shorter name. I don't know if that helps, but whatever helps you to memorize that, please do. So since we can change the neutrons and the electrons of a specific atom, we need to have a way to actually write them out. So I know for this atom, this is how many neutrons, protons, and electrons there are. So now we're back to that top on the first page, or the bottom of the first page. This is how we write it out. You write the symbol in the middle, the mass number goes on top, atomic number goes here, and then the charge goes to the right. Okay? So if I'm looking at this symbol right here, this is telling me that this specific fluorine, F is fluorine, this specific fluorine has an atomic number of 9. What does the atomic number mean again? Atomic number means the number of protons. So I have 9 protons. It has a mass number of 19. What does the mass number mean again? The mass number means protons plus neutrons. So I know that I have 19 protons and neutrons. And knowing this, I can find out how many neutrons there are. So if I take my protons plus my neutrons and I subtract my protons, I know that I have 10 neutrons. Okay? So now I know my protons, my neutrons. The last thing is my electron. So I look over here. Since there's nothing written here, the charge is 0 or neutral. We don't write that out. It's just stated or understood. And so that means that my atom has to have a neutral charge, meaning it doesn't have a positive or a negative charge. So that means the protons must equal the electrons, because the positive has to equal the negative in order to be 0. And so therefore, I have 9 electrons. So if I go to my examples down here, carbon has, oh my gosh, you didn't tell me how many protons. Calm yourselves. Look at the periodic table and find the atomic number. The atomic number for carbon is 6, so I can write that in there. I have 6 protons. 13 minus 6 is equal to 7. Carbon is a neutral atom, which means it has the same amount of protons and electrons. So he has 6 electrons. Next time, before you come to class, I need you to have finished the entire worksheet front and back. And number 2, review dimensional analysis, because you're using that in your activity next time. Thank you for tuning in, and we'll see you next time.